Welcome to chemistry classes. In this video we have to discuss here chapter 3 atoms, elements and compounds. Okay, here first we have to discuss here atoms. Atoms are the smallest part of any matter. We know there are three different states of matter: solid state, liquid state and gaseous state. All matter made up of extremely smallest part called atoms. You can see this figure. Atoms considered like hard sphere. Atoms considered like a hard sphere. Most of the space of atom is empty. Most of the space of atom is empty. In the middle of atom there is a hard center. Very small hard center in the middle of atom. This hard center called nucleus. Okay, so this is the representation of atoms. Next one we have to discuss here elements. Elements are the substance which consist of only one type of atoms. When you consider a gold bar, when you take a gold bar, this gold stick or gold bar which consists of only gold atoms, only one type of atoms. Such type of substance called elements. Okay, imagine this room which contain only oxygen atom, only oxygen gas. So here only oxygen atoms, only one type of atoms. So we can say it is element. So elements are the substance which contain only one type of atoms, that is element. There are more than 100 elements in the universe. Okay, so we can say hydrogen, helium, lithium, beryllium, boron, carbon, iron, gold, silver, platinum. There are many elements in the nature. Clear? So elements are the substance which consist of only one type of atoms. The first element we can say hydrogen. Hydrogen. Okay. Look here. Next one we have to understand here symbols of elements. Okay, you can see this is here, it is given periodic table. This is periodic table. Periodic table mean, I told you before, there are many elements, more than 100 elements. All these elements included in a table. This table called periodic table. Periodic table. Okay, in periodic table you can see here name of the element, also their symbols. We use different symbols to represent different elements. For example, hydrogen. Hydrogen, H. Look here, hydrogen. The first letter of hydrogen, when you write hydrogen in English, first letter H. So we can represent here hydrogen, H. Helium, again starting with H, so we cannot say again H. So first two letter, first letter in capital, second letter small letter. Okay, so helium. Next one carbon, carbon C. Calcium, Ca. Carbon starting with the C, so capital letter C. Calcium again starting with C. Carbon, calcium, both are starting with the C. Okay, so here carbon, the symbol of carbon, capital letter C. Calcium, here Ca. This is the symbol of calcium, Ca. Okay, so here C, capital letter, and here A, small letter. Okay, if there are two letters, first one will be capital letter, second letter will be small letter. Okay, sulfur and sodium. Sulfur, capital letter S. Okay, again sodium. Sodium, symbol not as sodium, symbol is Na, because the Latin name of sodium is natrium. Natrium. So we will use Na. Similarly, potassium. Potassium, not P. Potassium. Kalium, the Latin name of potassium, kalium. So we will use K to represent potassium. Okay, phosphorus, phosphorus, P. So remember phosphorus, P, potassium, K. Okay, so these are the symbols. These are some symbols of elements. So you can use this periodic table. You can see the name of the periodic, name of the elements. Also you can find their symbols in periodic table. Okay. We have to understand about periodic table. More about periodic table. Already we discussed periodic table. Here this is periodic table. In periodic table you can see different types of elements with their symbols. In periodic table, elements starting with hydrogen, helium, lithium, beryllium, boron, and so on. Okay, so elements starting, the first element in periodic table, hydrogen. Okay, so here we have to understand here period and group. In periodic table we can see period and group. Period mean horizontal rows in periodic table. See this periodic table, you can see elements like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, starting with the lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So this type of arrangement in periodic table, horizontal rows are called period. Horizontal rows are called period. Okay, and similarly you can see like this in periodic table. First one, in first group in periodic table, left side, first you can see lithium, sodium, potassium, rubidium, cesium and francium. This is vertical column. In periodic table, this vertical column called group and horizontal rows are called period. So in periodic table there is two terms, period and group. Okay, period mean horizontal rows are called period, vertical column called group. So this is example for group. This is first group in periodic table. First group. After first group, second group. You can see in this periodic table here, you can see in this picture there is first group, second group, third group, fourth, fifth, sixth, seventh. At the end you can see zero group. Okay, so group 1, group 2, group 3, group 4, group 5, group 6, group 7, then zero group. Okay. So this is first group. In first group, lithium, sodium, potassium, rubidium, cesium and francium. Okay. Also, next one we have to understand here, in periodic table we can classify elements, metals, non-metals and metalloid. In periodic table, left part of this periodic table, it is metal, and right side of the periodic table, right part of the periodic table, it is non-metal, metal and non-metal. Okay, also you can see here between metal and non-metal there is a zigzag line between boron, silicon, arsenic, tellurium. Between boron, silicon, arsenic, tellurium and astatine, you can see a zigzag line. This zigzag line, it separates metals and non-metals. These elements are called metalloids. Boron, silicon, arsenic, tellurium and astatine. These elements are called metalloid. Metalloid mean these elements shows both metallic and non-metallic properties. Okay. So in periodic table, left part of these elements are metals, and right side of the periodic table it is non-metal. Between metal and non-metal there is metalloid showing both metallic and non-metallic properties. Clear? After that we have to discuss here position of hydrogen. Look here in this periodic table, I told you left part of the periodic table it is metal, but also you can see here hydrogen also left part of the periodic table. We know hydrogen it is gaseous state, hydrogen it is non-metal, but hydrogen is left part of the periodic table with metals. Okay, so here hydrogen actually non-metal, it is gaseous state, but it shows metallic properties. We know all metals lose electron. All metals have positive charge after losing electron. Metals have positive charge. Example, sodium Na+, calcium Ca2+, copper Cu2+. Metals have positive charge. Generally non-metals they have negative charge. Okay, metals positive charge, non-metals negative charge. But here hydrogen lose electron and showing positive charge. Generally hydrogen H+, plus 1 charge. Okay. That's why here there is no fixed position. There is no fixed position for hydrogen in periodic table. Hydrogen actually non-metal gaseous state, but it included with metals. Okay, because hydrogen shows both metallic and non-metallic character. Okay, hydrogen it is non-metal, it is gaseous state. It make different type of chemical bond such like non-metals, but also hydrogen showing metallic character, metallic properties. Okay, like metal, hydrogen shows +1 charge, +1 oxidation state. Okay, next one we have to discuss here more about atoms. We have to understand more about atoms. We already discussed atoms are like positively charged sphere, or we discuss atoms considered like hard sphere. In the middle of atom there is very small center, it is called nucleus. Okay. After that we have to discuss here subatomic particles. Okay, here further studies about atoms, it observed that atoms consist of subatomic particles. Subatomic particles mean atoms consist of smallest particles such as electron, proton, neutron. Okay, the term atom first suggested by John Dalton, scientist John Dalton. According to this scientist, atoms are the smallest part, okay, and these atoms cannot divide again. Atoms are the smallest one, it cannot divide again, according to John Dalton. But later onwards, further studies discovered that atoms again consist of electron, proton, neutron. This electron, proton, neutron inside atom, these particles are called subatomic particles. Electron, proton, neutron are subatomic particles. So let us see here subatomic particles. Electrons represented by E, proton P, neutron N. Okay, also you have to understand electrons they have negative charge. Okay, proton they have positive charge. Okay, the quantity of charge is same but they have opposite charge. Okay, also you can say number of electrons and protons inside atom always same. Atoms consist of equal number of electrons and protons. Electrons have negative charge, protons have positive charge. That's why the net charge of atom will be 0. Atoms are electrically neutral. Atoms are neutral particles. Why atoms are electrically neutral? Even there is positively charged proton, negatively charged electron, but atoms, the net charge of atom always 0, or you can say atoms are electrically neutral. The reason for this, atoms consist of equal number of electrons and protons. Electrons have negative charge, protons have positive charge. That's why atoms are electrically neutral. Okay. And here I told you here the symbols of electron, proton, neutron. Electron E, proton P, neutron N. Okay. The charge of electron -1, proton +1, neutron chargeless particle. Okay, chargeless particle in atom, that is neutron. Neutron, no charge. Clear? After that, we have to understand here mass of electron, proton, neutron. Mass of proton is 1. Mass of proton is 1 and mass of electron is very small, 1 over 1840. The mass of electron is very small, very less mass. Okay, mass of proton and mass of neutron same, 1 unit. 1 unit. Okay, not 1 gram, not 1 kilogram. We have to say 1 unit. Okay, here 1 unit. And here the mass of electron is very small, 1 over 1840. This is charge and mass of electron, proton, neutron. Okay, next one we have to understand here arrangement of particles. Arrangements of particles. Were this electron, proton, neutron inside the atom? I told you atoms are positive. Atoms are considered like a hard sphere. In the middle of atom there is a positive center. Okay, very small positive center inside atom, that is nucleus. Okay, so inside nucleus we can see neutron and proton. Proton, positively charged particle, proton. This proton inside nucleus. That's why nucleus with a positive charge. Okay, the middle of atom there is very small center. It is nucleus with a positive charge. Why nucleus positive charge? Because positively charged proton inside nucleus. That's why nucleus has positive charge. So neutron and proton inside nucleus. Okay, and also you can see here in this figure, this diagram represent atom. In the middle of atom you can see nucleus. Inside nucleus there is neutron and proton. Around nucleus there are circular path. This circular path called orbit or shell. Okay, orbit or shell. This circular path around nucleus we have to say orbit or shell. Electrons are revolving through this circular path. Electrons are revolving through orbit or shell. So electrons are found in orbit. Okay, and neutron and protons are found in nucleus. These are the arrangement of particles. Next one we have to discuss here proton number. Proton number, or we have to say atomic number. You can see this type of numbers in periodic table. I told you before, you can see many symbols of elements with their name. Symbols of elements with their name. Also the symbols of elements which consist of two numbers. This type you can see carbon 612, aluminum you can see 13 and 27. Also you can see here periodic table you can see different type of number. Oxygen 816, carbon 612, nitrogen 1428. Okay, this type of numbers, from this numbers we will get many information. Here I told you here carbon 612. Here this 6 called atomic number, or we have to say proton number. Atomic number or proton number. Proton number mean here number of protons inside carbon, inside the nucleus of carbon, it will be 6. Carbon 612. Here lower number always called atomic number or proton number. Higher number, here 12, higher number, it is mass number. Mass number also called nucleon number. Nucleon number. So in periodic table you can see many symbols with different numbers. Okay, for example aluminium 13 and 27. This lower number 13, it is lower number 13 and 27. 13 lower number, 27 higher number. Okay, this lower number always atomic number. Always atomic number, lower number. Atomic number also called proton number. Proton number. Here carbon atomic number 6 mean this carbon contains 6 electron and 6 proton. Generally number of electron and protons are same. Same number of electron and proton. Okay, that's why here 6 electron, 6 proton. You understand? Similarly here aluminium 13 and 27. So here aluminium which contain 13 electron and 13 proton. Clear? Also here higher number mass number. Mass number also called nucleon number. Mass number also called nucleon number. Okay, nucleon number or mass number mean this is the total number of neutron and proton. Okay, here mass number mean total number of neutron and proton. Neutron and protons are inside nucleus. That's why this number called nucleon number. Okay, so here mass number of carbon 12. Mass number of aluminium 27. Clear? Okay, next one we have to understand here how to find number of electrons, protons and neutrons from periodic table. You are asked to find number of electrons or protons and neutrons from periodic table. You want to find number of electrons, protons of sodium using periodic table. So how can you find it? Use your periodic table. Using periodic table, you can find the symbols of elements sodium, Na. Okay. Also in periodic table, you can see sodium, Na. There is two number 11 and 23. Similarly, aluminium 13, 27. Oxygen 8, 16. Carbon 6, 12. Copper 29, 64. You can find these symbols with their atomic number and proton number, atomic number and mass number. We discuss lower number, atomic number, higher number, mass number. Using atomic number and mass number, we can find number of protons, electrons and neutrons. Clear? So see here, sodium, its atomic number, sodium atomic number 11. So I told you before, atomic number 11 mean atomic number, it will be equal to number of electrons and proton. Atomic number 11 mean 11 electron, 11 proton. Okay, so see here, sodium atomic number 11. So 11 electron, 11 proton. Clear? Similarly, aluminium atomic number 13. 13 proton, 13 electron. Similarly, here 6 electron, 6 proton, 29 electron, 29 proton. So we can find very easily number of electron and proton using periodic table. Atomic number equal to number of electron and proton. To find neutron number, look here. Mass number minus atomic number, it will be neutron number. You want to find number of neutron. So 23 minus 11, 12. Here 27 minus 13, 14 neutron for aluminium. Carbon 12 minus 6. Copper 64 minus 29. So here 35 neutron. Clear? So using periodic table you can find number of neutron, proton and electron. Look here, this is mass number. Sodium atomic number 11 and 23. Atomic number, it is equal to number of electron, also number of proton. Clear? And this is mass number of neutron plus proton. That is mass number, neutron and proton together. That's why we call this nuclear number. So here I told you 23 minus 11, it is 12. This is number of neutron. 23 mean, you know, number of neutron plus proton. Number of neutron plus proton, that is nuclear number, that is mass number. When you deduct this with 11, what is 11? 11 mean number of electron, number of proton. So it is equal to number of protons or electron. So this proton number will be cancel each other and you will get number of neutron. This is number of neutron. So simply when you deduct 23 minus 11, number of neutron. Okay. 64 minus 29, 64 minus 29 for copper, so 35 neutron. So you can find number of neutron this way. Clear? Okay, next one we have to discuss here isotopes. Isotopes. See here example for isotope carbon 612, carbon 614. Here same element carbon exists in different form. Here carbon different form of same element. Here this is carbon, this is also carbon, their atomic number same, but they have different mass number. Here mass number 12, here mass number 14. This type of elements, this type of atoms are called isotopes. Different atoms, these are different atoms, but they are same element, they are carbon. They have same proton number, but they have different mass number. These are called isotope. Isotope means different atoms of same element with different mass number called isotope. Okay, these are the isotopes of carbon. And another examples for isotope H11, H12, H13. These are the three different isotopes of hydrogen. Hydrogen shows three different isotopes H11, H12 and H13. These are the three different isotopes of hydrogen. Okay, H11 called protium, deuterium and tritium. These are the three different isotopes of hydrogen. Only one element with no neutron. Only hydrogen, there is no neutron. Look here, H11, number of proton 1. We know hydrogen, atomic number 1. So number of electron 1, number of proton 1. But number of neutron, we know how to find number of neutron. Mass number minus atomic number. Only for hydrogen, atomic number and mass number same. Okay, so 1 minus 1. Number of neutron will be 0 for hydrogen. Number of neutron for hydrogen 0 for protium. Okay, generally we will represent hydrogen H11. So only hydrogen atom, there is no neutron. Okay, so isotope, the definition for isotope, different atoms of same element have same number of atomic number but different number of mass number. Okay, so here atomic number same, or you can say proton number same. Atomic number and proton number same for isotope, but neutron number, look here 12 minus 6, neutron 6, 14 minus 6, 8. So number of neutrons will be different, or you have to say number of mass number different or neutron number different for isotope. Atomic number or proton number same. So for isotope, atomic number or proton number same, mass number or nucleon number will be different. Clear? This is about isotope. After that, we have to understand here radioactive isotope. Radioactive isotope means some isotopes are not stable. They will not stay same during the time. For example, here carbon 14. Carbon 14, it is radioactive isotope. Radioactive isotope means this isotope, this carbon 14 atom or carbon 14 isotope, it emit radiation. It emit harmful radiation. Harmful radiation we will call alpha, beta and gamma. Alpha radiation, alpha, beta, gamma, these are harmful radiations emitted by radioactive isotope. After emitting harmful radiation, this isotope will change to another atom. This atom, this nucleus will change to another nucleus. Such type of isotopes are called radioactive isotope. So radioactive isotopes are not stable. It emit harmful radiations, alpha, beta and gamma radiation. After emitting harmful radiation, this radioactive isotope changes to another isotope. Okay, this element will change to another element. Such type of isotopes are called radioactive isotope. Okay, and here we have to understand radioactive isotope. We will use this. We have different uses for radioactive isotope. Radioactive isotope used for cancer treatment. Okay, the radioactive isotope of cobalt 60. Here CO mean cobalt. Okay, and mass number is 60. Cobalt 60 used for treatment of cancer. For cancer treatment we will use cobalt 60. And another one, carbon 14. We can detect age of fossil fuels. You can see here one figure, here dead bodies or fossils or dead remains of plants or animals. We can detect the age of this living things, how long it before, using this carbon 14. This process is called carbon dating. Carbon dating. Okay, so here cobalt 60 cancer treatment, carbon 14 used for carbon dating. Carbon dating. Okay, and another one, uranium 235. Uranium 235, another radioactive isotope. Uranium 235, it used as nuclear fuel. Okay, so here nuclear fuel. You can see this figure here, this nuclear reaction. Here in this nuclear reactor, there are many chemical reactions like nuclear fission, okay, and it produces large amount of energy and we can utilize this energy. Okay, so this is nuclear reactor. So in nuclear reactor we will use uranium 235. Okay, also another radioactive isotope, iodine 131. Iodine 131, this is another radioactive isotope. Iodine 131, this one used for treatment of thyroid gland. Treatment of thyroid gland. So these are the different uses of radioactive isotopes. Next one, we have to understand here arrangements of electrons in an atom. How electrons are arranged in atom. Okay, to understand this, look here, I told you before, this is the structure of atom. In the middle of atom there is a positive center. This positive center called nucleus. Inside nucleus we know there is neutron and proton. Okay, and around nucleus there are circular path. This circular path called orbit or shell. Inside orbit or shell we can see electron. or you can say electrons are revolving through orbit. Okay, you have to remember first orbit 2 electron, second orbit 8 electron, third orbit again 8 electron. Okay, there is certain equations or certain reason to say why first shell 2 electron, why second shell 8 electron and again 8 electron. These reasons we will study higher classes. Now you just remember first shell 2 electron, second shell 8 electron, third shell again 8 electron and so on. Okay, so here this is first shell. Here first shell, second shell, third shell, or sometime it is called first shell, K shell, K, L, M, N, etc. So first shell 2 electron, second shell 8 electron. Look here, this is 2 electron, second shell 8 electron, third shell again 8 electron. Okay, so this is the arrangement of electrons in an atom. Okay, next one we have to understand here electronic structure. Electronic structure of sodium. Electronic structure or electronic configuration mean, look here, sodium, this is atomic number, sodium atomic number 11. So first shell how many electron? First shell 2 electron, second shell 8 electron, third shell again not 8. You have to remember here sodium atomic number 11. So atomic number 11 mean first shell 2, second shell 8. Okay, so here 2 plus 8, 10 electron. 10 electron already here. First shell, second shell, 2 plus 8, 10. We know here already 11 electron. Only 11 electron. So 11 minus 10, 1 electron. So 2, 8, 1. Okay, similarly look here, magnesium atomic number 12. Magnesium atomic number 12. So first shell 2 electron, second shell 8 electron, 2 electron, 8 electron, third shell 2 plus 8, it is 10. We have only 12 electron, 12 minus 10, so it is 2, 2, 8, 2. Similarly here 2, 8, 3, 2, 8, 3, 13. Okay, similarly here 2, 1. Okay, lithium atomic number 3, 3 electron, 2, 1. Do not write here 2, 8. 2, 8 mean 10 electron. Lithium only 3 electron, not 10 electron. So you have to write here 2, 1. Calcium only 20 electron, 2, 8, 8. 2, 8, 8 mean 18. How many left? 2 more. So calcium 2, 8, 8, 2. So it will be 20 electron. Clear? Last one, beryllium. Beryllium, look here, atomic number 4. Atomic number 4. So 2, 2. Okay, so this is electronic structure, or you can say electronic configuration. So using periodic table you can find atomic number. Using this atomic number you can do electronic structure of any atom. Clear? So these are the things we have to discuss in this video. Rest of the part we will discuss another video. Okay, so in this video we discussed atoms. What is atom? What is element? What is atomic number? What is proton number? What is nuclear number? What is isotope? Radioactive isotope. Different uses of radioactive isotope. Finally, we discussed here electronic structure of different atoms. Arrangement of electrons in an atom. Okay, so you can revise all these things. You can just review this video again. So thank you for watching this.
Thank you for watching this channel. Please subscribe and press the bell icon for more videos. Thank you.